How do firefighters calculate friction loss accurately? Imagine trying to push water through a hose and wondering how much pressure you need to keep the water flowing strong. That's what firefighters think about when they calculate friction loss. It's all about understanding how much pressure drops as water moves through the hose. To do this accurately, they use a specific formula that takes into account three main things: how fast the water is flowing, how long the hose is, and the size of the hose itself. The common formula they use looks like this. Friction loss equals a number called the coefficient times the flow rate divided by 100, squared, then multiplied by the hose length divided by 100. The coefficient is a number that depends on the hose size and how smooth or rough the inside of the hose is. For example, a typical 1 3/4 inch attack line might have a coefficient around 12.5. Firefighters get this number from manufacturer data or national standards. They then multiply this coefficient by the scaled flow rate and hose length to find out how much pressure will be lost. To make things easier during a fire, firefighters often use charts or tables that show friction loss values for common hose sizes and flow rates per 100 feet of hose. These tables help them quickly estimate how much pressure they need without doing complex math on the spot. Friction loss depends on a few factors. Longer hoses cause more pressure loss, and higher flow rates increase it exponentially because the loss goes up with the square of the flow rate. Larger hoses help reduce friction loss because they have a bigger diameter, which makes water flow easier. The condition of the hose also matters. Worn or rough hoses cause more friction, so the coefficient might be adjusted based on testing or experience. Fire departments sometimes test their hoses to verify the actual friction loss values, ensuring their pump pressures are set just right. Knowing how to calculate friction loss accurately helps firefighters set the correct pump discharge pressure. This way, they deliver enough water to fight the fire effectively without damaging equipment or creating unsafe situations. So, by applying the coefficient formula, referencing tables, and testing their hoses, firefighters can keep water flowing smoothly and safely during any emergency.